Okay, now we're going to talk about the second question on resultant force using vector diagram. So this is the question that I would like to deal with. Okay, just want to focus it a bit. Now, in this case, the two forces are not pointing to a vertical or horizontal position. So because of that, you need to draw your reference line. Okay, in this case, your reference line should be the horizontal line. So as I mentioned the steps before, you need to select the appropriate scale, draw a reference line, in this case will be the horizontal, construct the first line, second line, join the lines, measure and convert, and finally measure and express the direction. So let's try now. You may want to freeze the video and roughly sketch out the question and do together with me. Okay, so let's start. Now, because this is a 100 Newton force, so we need to consider how we're going to convert to appropriate scale. So if let's say we use 10 cm to represent 100 Newton, and this is half a A4 size paper as I mentioned, you'll realize that it is just nice, okay, because one of the force will almost occupy half of the paper. Okay, so the appropriate scale to use will be 1 cm to 10 Newton. Okay, so with this, first we need to draw our reference line. So the first reference line, I'm drawing it higher a bit because the first force will be down here, so we need a lot of space below and not above. Okay, so I'll draw the reference line first. You realize that I'm using a dotted line to represent the reference line. The reason is because this is not actual force, this is only a imaginary line for you to reference. So because of that, you should not draw a solid line to reduce confusion. So next, let's say you take this beginning of this point as the starting of your first force. So the first force is 40 degrees from the reference line. So you place your protractor and you measure 40 degrees. And then you draw down your first force. Okay, so I got to be very accurate for this one. So you get your first 100 Newton, and this is 40 degrees. So how about the next force? The next force is 40 degrees above the horizontal. So first of all, you need to draw a second reference line here in order to be able to draw this force accurately. So how do you draw the second reference line accurately? If this is 40 degrees, this line and this line will align. So obviously, your second reference will have to be 140 degrees from here, because this is a sum of two interior angles. Alright, so once you draw the second reference line, you can start to draw your second force. So again, we draw the angle and then we draw the force. Okay, so I'm going to draw now. Alright, so 40 degrees, 40 degrees. So if you get your construction accurate, you should have a line that runs along the horizontal reference line as the resultant force. So now I'm going to join the two. Alright, so this will be your resultant force. Okay, and then you can measure the resultant force, which in my case is 15 cm. So 15 cm we reconvert back will be 150 Newton. So my resultant force will be 150 Newton. And the direction, okay, if you have your construction really accurate, you realize that the direction should be horizontal. Okay, another way to express it is you can say that it is 40 degrees anti-clockwise from 10 Newton force. But unfortunately, because you have two 10 Newton force here, okay, sorry, this is 10 Newton, 100 Newton force here, you may confuse yourself because these two forces are the same value, so you cannot reference to this force when they are the same value. They don't know which one you are talking about. So in this case, if you have constructed it accurately, the direction should have been horizontal to the right. Alright, so this will be your answer. Okay, so that's the end of this video. Please carry on with the third video on even more complex construction. Thank you.